The compute hierarchy, how energy becomes logic in the modular blockchain stack. Section 1, Introduction. All computation begins as energy. Every digital process, from mining Bitcoin to training an AI model, traces back to electricity channeled through hardware to perform structured work. Blockchains at their core are energy-to-order machines, systems that transform physical power into digital trust. Over time, these systems have evolved into distinct layers of computation. Bitcoin uses energy to secure and timestamp truth. Ethereum converts computation into programmable logic. Render and others like it transform hardware capacity into productive utility. Together, they form a hierarchy, a spectrum of computational specialization that mirrors the broader architecture of modern computing itself. This exposition explores that hierarchy, explaining how blockchain networks differ in what kind of computation they monetize, why these differences lead to disaggregation between compute, execution, and verification layers, and how this modularization creates both commoditized and premium segments in the decentralized economy. Section 2, the physics of computation, energy as the root resource. Every computational act begins with energy. Electricity powers CPUs, GPUs, and ASICs, which in turn perform the mathematical operations that give rise to software, logic, and digital coordination. In this sense, the blockchain ecosystem can be seen as a compute supply chain. Energy becomes hardware, hardware becomes computation, computation becomes logic, logic becomes coordination, and coordination becomes value. Energy provides the base layer, the physical substrate. Computation is the transformation of that energy into measurable work. Logic organizes that computation into purpose, and coordination, the final layer, turns logic into consensus, contracts, and markets. Blockchains are therefore not abstract networks, but structured energy systems, where the cost and design of computation define the economic model itself. Section 3, Layer 1, Bitcoin, Energy as Security. Bitcoin represents the first and most fundamental layer in this hierarchy. Energy-backed computation. Its proof-of-work system transforms electrical energy into hash power, which miners use to secure and sequence blocks of transactions. The result is a tamper-resistant ledger, made reliable not by authority, but by the immutable cost of computation. Each hash is a lottery ticket purchased with energy. Each block is the outcome of millions of energy-driven guesses that prove, beyond doubt, that work was done. This process turns electricity into a scarce digital resource, truth with thermodynamic backing. Bitcoin's computation isn't useful in a conventional sense. It doesn't render images or execute code, but it's valuable because it anchors digital trust in physical cost. It is computation as verification, a market for security itself. Section 4, Layer 2, Ethereum. Computation as logic. Ethereum took the next step. It made computation programmable. Where Bitcoin turns energy into ordered truth, Ethereum turns computation into logical execution. Each transaction consumes gas, a measure of compute cycles within the Ethereum virtual machine. These cycles execute smart contract code, automated agreements that can hold funds, enforce conditions, and coordinate actions without intermediaries. Yet this power introduces a paradox. Adding more nodes does not make Ethereum faster, it makes it safer. Every node re-executes every transaction to ensure consensus. The bottleneck is not CPU speed, but verification overhead. Thus, Ethereum's premium lies not in raw computation, but in trustful computation, logic validated by consensus. The gas fee is not just a payment for processing power, it is a toll for entry into a global court of deterministic truth. Section 5, Layer 3, Render, Computation as Productive Work. Render represents a different branch of the hierarchy, one focused on productive computation. Instead of using energy for security or logic, Render monetizes the idle GPU cycles of artists, studios, and data centers. It aggregates spare graphics processing power into a decentralized marketplace where users can rent compute capacity for rendering, AI inference, or simulation tasks. This model resembles centralized cloud platforms, but without centralized control. Participants contribute hardware, the network coordinates workloads, and the render token manages pricing and payments. Where Bitcoin is a market for truth and Ethereum a market for logic, Render is a market for power. It bridges physical computation with economic coordination, proving that decentralized systems can extend beyond finance into the broader industrial landscape of digital labor. Section 6. Expanding the compute economy, other computational marketplaces. Render is not alone. A growing constellation of protocols now monetize specific computational functions. Filecoin and Arweave create markets for storage, turning disk space into verifiable work. BitandSoar creates markets for AI intelligence, rewarding networks that contribute useful model outputs. Golem and iExec create general-purpose compute markets. Helium and WeatherXM form proof-of-coverage networks, verifying physical data presence. Mina and ZeekSync operate proof generation networks, turning computation into verifiable cryptographic compression. Each represents a distinct species of compute marketplace, different expressions of how energy, hardware, and logic can be structured into coordinated economic systems. Together, they form a computational ecology, each specializing in a particular type of work. This content is brought to you by Bobby Giggs. Promote your brand here and reach a wide audience across platforms like YouTube, Instagram, and Facebook. Follow the links in the description to get started. Section 7. Separating compute, execution, and verification. As these ecosystems matured, a structural pattern emerged. Monolithic chains like early Ethereum were inefficient. They combined execution, verification, and data availability into one tightly coupled system. To scale, blockchains began disaggregating these functions. The compute and execution layer runs the logic, smart contracts, and transactions. The verification layer checks correctness and consensus. The data availability layer ensures everyone can access the inputs and outputs. Projects like Celestia and EigenLayer embody this modular shift. Instead of one blockchain doing everything, networks now specialize. Compute-heavy operations move off-chain or onto layer 2s, while Ethereum focuses on verification and settlement, the kernel of truth. This mirrors the evolution of cloud computing, where storage, compute, and coordination became separate services. Section 8. Commoditization versus premium layers in the modular stack. When functions are separated, value stratifies. Computation becomes commoditized. Anyone with hardware can provide it, and price competition drives margins down. Logic and verification remain premium. They handle governance, trust, and consensus, areas where neutrality and security are scarce and valuable. It is the same economic pattern seen in traditional industry. Cloud servers represent low-margin infrastructure. Platforms and protocols represent high-margin control layers. In blockchain terms, energy and compute are abundant, but trust is scarce. That is why Ethereum's verification layer commands a premium, while GPU networks compete on cost. Section 9. EVM-compatible chains, forked operating systems. EVM-compatible chains like Binance Chain, Tron, and Polygon illustrate this stratification in action. They all run the same Ethereum virtual machine logic, the same operating system for smart contracts, but on different consensus and infrastructure setups. By using faster block times and fewer validators, they gain performance at the cost of decentralization. In doing so, they effectively decouple execution from validation. The compute runs locally, while consensus operates with less redundancy. These chains are like forked operating system distributions, running the same software under different regional conditions. They exist to serve diverse user bases, like regional data centers for a global network, making the EVM not a single system but a standardized computing language for logic. Section 10. Multi-chain applications as decentralized multinationals. Applications like Aave, SushiSwap, and Uniswap have evolved into multi-chain enterprises. Originally deployed on Ethereum, they now operate on multiple EVM-compatible chains, each with its own liquidity pools, users, and conditions. Ethereum remains their headquarters, where governance, accounting, and treasury decisions happen, while other chains act as regional branches serving local markets. Bridges connect these branches like supply chains, moving capital and data between ecosystems. Liquidity fragmentation mirrors foreign exchange risk. DAOs function as global corporate boards, balancing regional independence with unified strategy. In short, decentralized finance has become a network of blockchain multinationals, decentralized organizations scaling across digital jurisdictions. Section 11. Synthesis, the modular blockchain stack. Across all these examples, a clear hierarchy emerges. Energy becomes compute, compute becomes logic, logic becomes verification. Verification becomes coordination, and coordination becomes value. Each layer depends on the one below it, but commands a different economic dynamic. Energy and compute are abundant, logic and coordination are scarce, and verification turns scarcity into trust. The result is a modular blockchain stack, an open global compute economy where specialization drives efficiency and interoperability drives scale. This mirrors both the architecture of the internet and the structure of modern corporations, a convergence of physical energy, digital logic, and economic coordination into one continuous value chain. Section 12. Conclusion. The future of value in the compute hierarchy. As the blockchain ecosystem matures, the hierarchy of computation will define its economics. Energy and compute markets will expand, but commoditize. The verification and coordination layers, where trust, logic, and governance reside, will command the premium. Understanding this stack reveals not just how blockchains work, but where future value will accrue. At the top, where computation becomes coordination. At the core, where logic becomes trust. The path from energy to logic is also the path from physics to finance. In that transformation lies the blueprint of a new digital economy, one where energy becomes logic and logic becomes value.